I hope everybody is fine. And uh, in this video, I'll be just uh, talking about the transistor configurations. Since the transistor is a three-terminal device, therefore we can have three types of configurations for a transistor. And and out of them, the very first configuration I would like to discuss here is the common, common emitter configuration. And in this configuration, what is important is that this emitter terminal of the transistor is common between the input and output circuits, right? So if I have to go for this configuration, I would like to have a transistor, and let me assume that we make use of a PNP transistor, and this will be its emitter. So the current here will be emitter current, and this will be base. So the current here will be base current, and then here we will have the collector, and the current here we will have in this case will be collector current. So now what is important in common emitter configuration, this emitter should bifurcate the input circuit and output circuit, right? So in order to do that, uh, so what is important in this case is that uh, uh, this input circuit should be forward biased. So for being forward biased, this should be negative, and 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 here I should have positive terminal, right? So with this, making use of this polarity of the battery, uh, I have the input circuit for this common emitter configuration in forward biasing mode, because the positive goes to the P and negative goes to the N region of this transistor. And then talking about its output circuit should be reverse biased. So in that case, this should be grounded, and in that case I have I would go with a load resistance RL, and then I will have another battery here. But I have to make sure that the output circuit of this transistor is reverse biased. So for that, I must give negative here, and then the rest of the thing is clear. So, so this is my common emitter configuration. This I can call as load resistance, and from here we will have the output across this RL. So here I will have the output. So this configuration is the common emitter configuration of a transistor. So here we have a PNP transistor. Now, we can clearly see that this is the emitter, this is the base, and this is the collector. This emitter is bifurcating the input circuit and the input circuit from the output circuit. This is why it is called as common emitter configuration. Now, the next configuration is the common base configuration, and we would like to go for its circuit diagram and see how we are able to bifurcate this input circuit from the output circuit. So common base configuration. All right, so we have here we have a transistor, okay, and in this case we have the base, and we have to make sure that the base is common between input and output circuit. So you can see here, so here I have the base current IB, and then here if I mark this arrow in the outward direction, this is base and this is emitter, and this is collector. So here if I mark it like this, so it is a PNP transistor. So what we have to do, we have to make sure that its input is forward biased. So for that I will be using here positive, and this will be the input circuit. So here it will be positive, and why I'll connect it like this, and then the output circuit should be reverse biased. So that's an important condition. So here I would like to have a load resistance, and then I would like to have, so this is PNP. So you will have holes here. These holes have to be attracted. So for that purpose, we need positive from this side. And then finally I can join it like this. Now here we can see that there is a voltage between emitter and base. So this is VEB. This is the voltage across emitter and base. And here we will have VCB. So that is collector base voltage, right? And so I can call this as this is my VEB. I can name this battery as B1, and here I can name this battery as VCB as B2. So clearly this is IB, this is IE, and this is IC, right? So we have the common base configuration, and we can clearly see that the input circuit is bifurcated from the output circuit by the base terminal. So this is why we call this as common base configuration of the transistor. And finally we have the common collector configuration. So we would like to go with that. So we can clearly see that the input circuit in this case is forward biased, and the output circuit is reverse biased. Now moving on to the third configuration, and that is common collector configuration. So as the name suggests is we understand that that in this case collector should be common between the input and the output circuit. So let me draw it. So let me assume that this is the collector, right? And this is the base, right? And this is the emitter. So here, if I show a polarity like this, it will be an NPN transistor, right? Because of having this